Again, we have another integral expression, and this is just similar like the previous video. You have 1 on e exponent x plus 1. In order to solve this one, you can still use the identity approach. So you say that the top one, the numerator, has an element of 1, and here too you also have another element of 1. So what is missing is the second element, which is the e exponent x. So you can introduce that in the numerator, but when you introduce that, you should know that since the operation between e exponent x and 1 is an addition, so we use the identity element for addition, which is 0. So that means we'll be having, this should be equals to the integral of e exponent x minus e exponent x, which is 0. So plus 1 on e exponent x plus 1 dx. So we did not do anything to this. Okay, we did not do anything to this. What we just did, we just rewrote a beautiful equation in another beautiful way. So now is to rearrange the terms up here so that it should just look like the denominator. So we have e exponent x plus 1. Okay, so we separate that from this. So you'll be having the integral of e exponent x plus 1 on the denominator e exponent x plus 1, then minus e exponent x on e exponent x plus 1. So all this dx. Then we further simplify before we integrate. So we have this be 1, so that will be the integral of 1 times the dx, so dx, minus the integral e exponent x on e exponent x plus 1 dx. Now the left hand side is easier for us to integrate, so that is not a problem. So we have x minus, then the right hand side is what we need to simplify now. So here, since we have a independent variable on both sides of the fraction, so numerator and the denominator, we can use the algebraic substitution. So the u substitution, do the u let u equals e exponent x plus 1. Okay, that's the denominator. Then we differentiate du on dx should be equals to e exponent x. So we make the x, since there is the x here, so we make the x the subject. So we're having du on e exponent x equals dx, and that will be the substitution for this. So in place of e exponent x plus 1, it should be u. So we have e exponent x on u, then times du on e exponent x, so that this and this will cancel out, and we'll be having x minus the integral of 1 on u du. So when we simplify this, so we should get x minus the ln of u, then plus c. But remember that u is equals to e exponent x plus 1. So we just do the substitution, and that's that. So x minus ln of e exponent x plus 1 plus c should be absolute because we don't have a negative, the log of a negative number, so absolute. Then this is our final answer. And that's that. Thank you.